Earth is unique among the known planets. There are over 3,000 minerals known. Some are rare and precious, such as gold and diamond, while others are more ordinary, such as quartz. Do you know of any more examples of minerals from the Earth? Generally, the carbonate minerals are found at or near the surface. They represent the Earth's largest storehouse of carbon. Calcite, dolomite, and aragonite are the commonest varieties of carbonate minerals. There are more than 80 types of carbonates mineral in the earth, but most of them are rarely found. Most of the rock-forming carbonates belongs to one of two structure groups, either calcite or aragonite. But what is carbonate metals? Carbonate is an ion consisting of one carbon and three oxygen atoms. The molecular formula for the carbonate ion is CO3 negative, which readily loses electrons to form positive ions, which is cations. Metals are otherwise defined according to their position on the periodic table, including groupings as alkali metals, alkaline earth metals, transition metals, and rare earth metals. Metal carbonate is generally decomposed on heating, liberating carbon dioxide from the long-term carbon cycle and leaving behind an oxide of metal. This process is called calcination. Most carbonates are insoluble on water at standard temperature and pressure, with solubility constant less than 1 times 10 to the minus 8.
Back then, scientists have found out the thermal decomposition of metal carbonates. Thermal decomposition, or thermolysis, is a chemical decomposition caused by heat. The decomposition of metal carbonates can be conducted in the lab. All typical carbonate metal, when heated, will produce carbon dioxide and metal oxide. The presence of carbon dioxide in the metal carbonates can be proven by channeling the gas produced into lime water, and the lime water will turn chalky.
Now, let's have a look on some of the uses of the products from heating metal carbonates. Copper carbonate. When copper carbonate undergo thermal decomposition, it will become copper oxide, which can be used as manufacturing of glass, paper, rayon, detergents, and soaps. It is also widely used as water softener. Magnesium carbonates. When magnesium carbonate undergo thermal decomposition, it will become magnesium oxide, which can be used as antacids, drying agent, and dietary supplement. Meanwhile, sodium carbonate does not undergo thermal decomposition. Therefore, it will remain as sodium carbonate, which can be functioned as welding with copper alloys, food and drinks, and textiles.
Back to the earth. When all metal carbonates are naturally formed, such as calcite, dolomite, magnesite, azurite, anchorite, cerussite, smithsonite, and siderite. Now, let's uncover the effect of heat on metal carbonates towards the environment. Sure enough, the impact that it brings towards land and sea. However, today we're going to focus on the effects that it brings towards the sea. Now, let's talk about calcite. When calcite is heated, it produces calcium oxide and carbon dioxide. When carbon dioxide exists within the seawater, it will react with the water to form carboxylic acid. Too much of carboxylic acid will disrupt the ecosystem within the sea. For example, the greater the acidification reduced will disrupt the growth of the species within the seawater. Now let's talk about oysters, right? Their size is reduced when acidity is too high within the seawater. Therefore, one of the effects of heat on metal carbonates is increasing the acidity of seawater, which clearly see that it is much more detrimental. These effects are much more detrimental towards the environment. However, we cannot deny that within the future, scientists might be able to find good effects that come from this heating of metal carbonates.